that minus sign so that we truly can have the first term subtracted by the second term. So let's focus on this secret 1, which every time you have minus sign, you're going to need to put that secret 1 in there and then distribute the minus. So all 3 of these change signs because we're multiplying by a negative. What does the 7x cubed become, Jalen? Negative 7x cubed. What about the 5x squared, young man? Keep going. Minus 5x squared. And finally, don't fall for the trick. What happens to the 12? Tell us why. To reiterate, he takes the -1 and multiplies it to each one of these terms inside, and this trinomial, now the signs have switched. The -12 became a +12 because double negative. Did we combine anything from the first step? No, we're going to bring this down. All of it comes down neatly. And now it's a matter of simplifying. Well, we've already learned this on the previous skill. How do we simplify here? Can anyone articulate? Let's see a hand up. Go ahead, Nico.
By doing the highest exponents first and combining the
Excellent. Highest exponents first, combining like terms. Give us some more guidance here. What is the highest exponent?
The highest exponent would be
x3 or x cubed or x to the 3rd power. 1x cubed goes with what, Joe?
Negative 7x.
Negative 7x cubed. They go together for 2 reasons. What are those reasons? Let's hear from somebody new. Let's hear from somebody new. Delia, what are those reasons?
Same exponent and same variable.
A little louder, please.
Same exponent and variable.
Same exponent, 3, same variable, x. So we're going to combine those. 1 minus 7. X cubed, just like the last problem, doesn't change at all. It's simply 1, take away 7. 1 subtract 7. What is 1 minus 7? Negative 6. And to reiterate one more time, if you're struggling with the adding and subtracting, use the calculator. So these terms are now combined. We're now on to the next highest exponent. What is the next highest exponent? 2. Absolutely. The 3x squared is a minus 3x squared. The 5x squared is a minus 5x squared. These are like terms for the same reasons as before. Same variable, same exponent. What do those sum to? Take away 3x squared, take away 5x squared. Sarah? Negative 8x squared. So that becomes negative 8x squared. Again, the coefficients are changing, not the exponents. And then the final like terms, Monique, where are the final like terms? Plus 5x plus 12. Are those like terms? There are no more like terms. Not a trick. I mean, yes, kind of a trick question. She didn't fall for it. 5x has no like terms. The constant term plus 12 has no like terms. You're simplifying by adding and subtracting following rules. So that is this problem. Why can it not be put any further together? John, why can we not combine all of this together? Why are there no more like terms? Well, what makes like terms? Why are we out of them? Same 2 things. What are we looking for? Same variable with same exponent. X, X, and X. You think, oh, like terms, but what's wrong with it? Cubed, squared, and a singular X. All right, you ready to practice this? Just like this problem, you need to start with the distributive. Here's the next one, and it's going to take a little longer. Let me know when you finish. I've got the answer key, and you just holler at me as you finish this problem. Go ahead, get to it, work together. Come on. Yes, certainly. Go ahead. Which one is this? I'm sorry, 4?
Thank you so much.
4 right here. So 3x becomes 4x in here. And then this one is 7x, so 4x plus 7 is
Alright, make everything negative.
Alright, so now
and it says, okay, so
keep going. It's a video. Keep going. Keep going. You're so smart. Alright, so first we do negative.
you have
Negative 1 times negative 7.
I have 3m cubed,
7m.
so 3m cubed. Plus,
I'm already done with that.
so negative
Keep going.
4
And then we have negative 4.
and positive 7 in different signs. Because if you multiply here, you change the sign, but now you definitely need 4 plus 7. You owe me $4 and have 7. How much do you have left? 3. So that'll change that. But your next term, where it's correct, is 21 again. So again, you combine the like terms. This is positive 9. This is positive 12. Okay, this one is correct. And that's pretty much the rest of the lesson. Carry on.
Abstains. Okay. Yes. I have to say this because I'm sick. I cheated.
Oh, I like it. This is so cool. This is a great way to do it. All right, let me know if you need help or if I can assist you in any way. Please raise your hand. Yeah.
Yeah, I don't think this is
Plus 1m. And this one is a minus. What's 5 minus 5? What's m minus m? They cancel out. Don't put it, it's gone. You can write 0m, but 0m is so easy. Come on, Jay, get back to work. Okay, fix it up. Your first task, I like that you have the 1 there. You're going to change all the signs in here because you're going to multiply by that negative 1.
You get 11.
Yes, I'll be right with you guys to see all your hands. Let me go grab it.
No, I don't.
This is correct. Brilliant. All right. This next one was on the homework. It's actually this problem, so you can do both. But how do you find the perimeter of a figure? That's area. How do you find perimeter?
I keep getting to exponents.
Add up all the sides. With that being said,
Wait a minute.
you can add these all up. You're not going to get a full answer,
Oh,
but
wait,
you
I
can come
have
on.
to. Wait.
All right. Good. Ready for the check?
What is
You guys can move on to the next problem.
There's a 1 in front. 1 minus 1 is 0.
Great. Check, Jasmine.
Really good
Right
things
here,
to say.
m
Keep
minus
going.
m becomes 0.
Keep going.
So don't just cross it off.
Just
Rewrite
listen.
it. That's correct.
So 1 minus 1 equals 0.
Yeah.
Listen, you can't have 0 and it turns back into a 1.
Yes. All right, gentlemen. Okay, where are we at?
No, I didn't say yeah.
So you multiplied this negative 1, right? So all these signs switch.
Volleyball pole.
Okay? So plus, minus, plus, plus. Good. Now,
You need to come up with a different story.
She tried on me, but she already closed.
But you laughed at you just laughed at it,
m
yeah.
cubed. Where's the m cubed that it goes with? That one right there. Now you combine negative 4 plus 7. What's up? Yeah, m minus m disappears. All right. Can somebody raise their hand and put this on the board? Good job. Does anybody want to put this on the board? Billy? Hey, use multiple colors and really show your work. Hey guys, let me have your attention. Number 1. That really worked well, guys. Yeah, thank you for that. So take a quick look. Listen, Sahara's going to be up here to do this problem, but in the meantime, if you have your slides open, which you should, how do you find the perimeter of a figure? Add up all the sides. So you can do this, you can just write a simplified expression. Also, this was on the homework. And then that would bring us to the got it question, and then I'll let you know when it's time for the exit slip. So here you go, Sahara, and there's the pen. Again, please use multiple colors, okay? All right, and then if you need help when you're on these problems, let me know. Okay, thank you. 4 plus 7. Negative 4 plus 7. Starting. All of the signs will switch from positive 7, negative 4, positive m. Okay. Positive 3m cubed minus 4m squared. This is my What's 9 plus 4?
Yeah, you need to get that live.
It's all 5 plus 8. Hold on a second. 21. Also, what is this? This is not acceptable. What is your right hand? Is that One second. Yes. Awesome. So now the answers for the next one, there for the rest of them are in the comments, so you can get to it. Okay. All right. There's the arrow. The answer key and the answers are in the comments except for the exit slip, so you should be able to check your answers. Honestly, I wish you could play with these things. Yeah. Yeah, what's 0 minus, what's 5 minus 5? What's m minus m? m. It just cancels out. You don't even have to write plus 0. It just disappears. Number 1. That was better. Ellis, can you explain the first step done by Sahara when she did all these multiple colors?
You have to change every
Sign.
Yeah, every term sign, because the -1.
What is that operation? Like, what is that called? The name of that property? She used the distributive property on the -1, and Ellis explained that the signs switch on the interior. Also, take note that she's color coding, and that's going to help you guys identify like terms if you're struggling with it. As you finish the perimeter questions, please let me know. Sure. I'm sorry, you're on this one right here? You could reasonably, but you might end up confusing yourself, so you might want to just write it as an expression with only addition and subtraction. That side plus that side plus that side. But yeah, there are 2 -8s, which makes -16.
That's just.
Jasmine, this is good work. Keep going. No, not quite, because you did 4 squares. Not 4 squares. Oh, that is 4 squares. What's 4 squared? 16 times 9 is 144. How'd you get 3? 24 times 8, right? I'm getting 96. I don't know where you got that number. I think you did exponent. No problem. Guys, let her work in peace. And as you're done with your perimeter questions, just let me know. So the only thing that's you got it. This is good. This is good. But right here,
-8
minus m plus m.
Plus 8. So it's -8.
It takes your terms into 0. It shouldn't be here. It should just keep going. And then these are minus 11. The right answer. All right.
Smart.
As we approach the end of the class, so a couple things. First off, we're going to review her problem, which is done really neatly and really well. We already started with Ellis showing that she used distributive property right here to change the signs, and then she combined the like terms and they're color-coded. The one thing, Sahara, I'd like you to explain is, where did one of your terms go? I noticed you crossed off green. Can you give that greater explanation?
Okay, so since they're the same or since they're different.
Speak to the class, Sahara. Nobody can hear you.
So since they're different signs, they cancel each other out. Because it's like if you add -1 plus +1, they will cancel each other out.
Excellent. You guys have any questions for her about her work?
No.
See, Sydney's giving you a nice little golf clap. Thanks for coming up. All right. There is 6 minutes left in class. With that time, please acknowledge your homework assignment is the independent practice number 1 through 5 and number 6. That is your homework, which you have time to start at another time. Mixed review you can do later. We won't do those. This is what I want you to work on for the remainder of your time. The exit slip, it needs to go on a half slip of paper so you and your partner can split up a piece of paper. You got about 6 minutes or so to complete it.
What's the
Homework is independent practice. All it is.
What is it do?
No, that's fine.
Is it due tomorrow?